So example 10.1.4. So interpreting a negative slope. So for a set of sample data of elevation in feet and high temperature in degrees Fahrenheit for randomly selected cities, the following equation of the least squares regression line was computed. We're going to interpret the slope in the context of this data. Okay. So in this case, we are looking at the elevation in feet is our variable x, and the high temperature is y. And so they're telling us if we want to predict a value of y for a given value of x, we're going to take 77.37 minus 0.0039 times x, where x has to be between and including 3,000 and 7,000, which means in this the randomly selected cities they had, the smallest elevation they had was 3,000 feet and the largest was 7,000 feet. Okay, so again, slope is change in y over change in x, which in this case is going to be change in high temperature over change in elevation. And so that is always our coefficient on x, where again the coefficient includes the sign. So we've got negative 0.0039. That slope is always put over a positive 1. And high temperature, the units there were degrees Fahrenheit. And for elevation, the units there were feet. Okay. So that tells us that the slope tells us here that for every 1 foot increase in elevation, we expect the high temperature to decrease. Okay, so that takes care of the negative. So decrease by 0.0039 degrees Fahrenheit on average. So note, the word decrease takes care of the negative sign in the numeric value of the slope. So we're not going to say it decreases by negative 0.0039. So it decreases by 0.0039 degrees Fahrenheit on average.